All right, in this lesson we're going to talk about reading a floor plan. So if you are interested in renting an apartment or renting a house or buying a house, those apartments or houses all come with a floor plan that shows you the layout of the house. And if you look at, this is a typical floor plan here, or a representation of a floor plan where you have the living room, and it gives the dimensions of the living room, which would be 20 feet by 12 feet, a bedroom, a dining area, a kitchen. That's going to be a bathroom. You can see the tub, and all the parts that go with the apartment. Examining the floor plan kind of lets you know the layout of the apartment or house or whatever you're looking at. Determine where, how much furniture will fit in there, how you would arrange the furniture, and just see, a lot of times just see if there's enough space to fit you, or if you have a family, to fit your family. If you get to the point where you are building your own house at some point in your future, then you could design your own floor plan. There's computer programs out there that allow you to create your own floor plan, or you could do it by hand, of course, but probably easier on the computer. So let's look at some examples of some different floor plans and different situations you're going to run to in this assignment. Jerry's using the floor plans for his new home to help him purchase base molding for the place where the walls meet the floors. The plans are drawn using a scale of 1/4 inch, which represents 1 foot. He measures the walls on the floor plan with a ruler and finds that they total 23.5 inches. Now, this is on the floor plan. This is not the actual house. On the floor plan, the walls measure 23.5 inches. If the molding costs $2.10 per foot, how much will Jerry spend on the molding? So now this is a real-life situation where you're trying to figure out how much you're going to spend on the molding based on the floor plan, and you have a scale. 1/4 inch on the floor plan represents 1 foot in real life. So Jerry needs to use a proportion to convert the scale measurements to the actual measurements in feet. So what he needs to know is, how big is the actual measurements of the apartment or house or the room that he's putting this molding in. So when you're setting up the proportion, you can use the scale. 1/4 is 1 foot, and anytime you have these, if this converts to a decimal pretty easy, then you would want to do that. So 1/4 of an inch is 0.25. So 0.25 of an inch is equal to 1 foot in real life. So set one of your fractions up like that based on the scale, and that's going to equal the number of inches on the floor plan, the actual drawing, in relation to the actual number of feet in the room. So Jerry found out that the actual drawing, was 23.5 inches. So that's the inches on the floor plan. And to find the actual number of feet in real life, you would just set up that proportion. 0.25 over 1 equals 23.5 over x. And you can cross multiply 20.25 times x. Remember the butterfly? So we're going to cross multiply and divide. So 0.25x equals 23.5 times 1. Divide both sides by 0.25, and you get x equals 94. That's how many feet in real life. And if it costs $2.10 per foot, and there's 94 feet, you just multiply those two numbers together and get 197.40. And that's what the molding is going to cost him. So you can see the real-life application there. So this problem here, the length of a room is 17 feet. That's real life. When using 1/4 inch equals 1 foot scale, so here's your scale, what's the length of the room on the floor plan? So we're going to follow this same idea here. So 0.25 inch equals 1 foot. Okay. And that equals, we're given the length of the room in real life, which would be the actual number of feet, which would be on the bottom here. And that would be your missing number. So proportion. So you just cross multiply and divide. So when you multiply that and then divide by 1, that's going to give you your answer. So 0.25 times 17 is 4.25, and then divide by 1 would be 4.25. So 4.25 inches, that's how big it is on the floor plan. 17 feet in real life, 4.25 inches on the floor plan. Okay, let's look at another situation here. Gabriella plans to carpet her living room except for the quarter circle, 1/4 of a circle, shown in the corner. That area is going to be a wood floor where she's going to put a piano. So she's designing this room, and she needs to know, well, let's see what she needs to know. The radius of the quarter circle is 8. So that distance there is 8. If carpeting costs $9.55 per square foot, what is the cost of the carpeting that she's going to use in the living room? So she's carpeting this whole amount except for this quarter of a circle, 1/4 of a circle. So we need to find out what this part is right here. So first we're going to find the area of the whole thing. So remember, area for a rectangle is length times width. So this living room is 25 by 16. And then when we find the area of the whole thing, we're going to take away the area of this little quarter circle right here. So the area of the whole thing is 25 times 16, which would be 400. So the area of this whole big rectangle is 400. So now I need to find the area of this quarter circle. So remember, the area of a circle, the formula is pi r squared. That's the area of a whole circle. So r stands for radius. So the area, if this thing was a whole circle, I would use pi times 8 to the second power, which is what they're doing here. So if I do pi times 8 to the second power, this is pi r squared. This would give me the area of a whole circle. Okay, now, so if I just do this part, 3.14 times 8 squared is 64, I get 200.96. So the area of a whole circle would be 200.96, but I only need 1/4 of it. So I just need to divide that by 4 to get just this quarter circle here. So 200.96 divided by 4 is 50.24. So the area of this quarter circle here is 50.24. So to find the area that we're covering in carpet, we're going to do the area of the whole thing, 400, minus the area of that. So right here, 400 minus 50.24 would be 349.76. That's the area of the carpeted region. Okay, that's going to be the area of just the carpeted region, not this part. And she knows that it's $9.55 per square foot for carpet, and that's what we're trying to figure out, is how much it would cost her to carpet this. So I'm going to take this 349.76 and multiply it times $9.55 per square foot. It looks like what they've done is they just rounded it up because you want to make sure you have enough carpet. So they rounded up to 350. Multiply it times 9.55 equals 3342.50. So this is what she can expect to pay for carpeting in that area right there. So here is a geometry problem. Express the area of the shaded region shown algebraically. So the area of the shaded region would be this whole area minus the white box here. So if I find the area of the whole thing and then subtract the area of the little box inside, that will give me the area of the shaded region. So the area of the whole thing would be length times width. So 2x times x plus 3. The area of this part would just be 5 times x, which would be 5x. So I'm going to take the area of the whole thing, and then I'm going to subtract that 5x. Well, the area of the whole thing, I need to distribute this, and I get 2x to the second power plus 6x minus that 5x, which is the area of the little box. And then I get 2x squared. 6x minus 5x is just x. So the area of the shaded region would be 2x squared plus x. Okay, I know that's taking us back to some geometry applications, and this one really does here. Delgado's landscape design is building a large gazebo. So this is the shape of the gazebo, the floor. It's a regular octagon shown here. Each side of the gazebo is 10 feet. They need to purchase wood for the floor, so they're trying to fill in the floor area with wood, and it costs $14 per square foot for a special type of wood. So find the cost. So we're looking for the area of this octagon. So all 8 sides of a regular octagon are congruent, meaning if this side is 10, that's 10, that's 10, that's 10, that's 10. That's what the word regular means. So if it's a regular polygon, in this case an octagon, then that means all the sides are the same. you need its apothem. An apothem is a distance from the center of the polygon to one of the sides that form a 90-degree angle. So the apothem in this case would be 12. Okay, it's perpendicular to the side. Okay, the area of a regular polygon is 1/2 times the apothem times the perimeter. Remember, the perimeter was the distance all the way around. So if I want to find the area of this octagon, I'm going to take 1/2 times the apothem, which would be 12, times the perimeter. And the perimeter, since there's 8 sides and each side's 10 feet, the perimeter would be 80. So 1/2 times the apothem times the perimeter. And if I multiply all those together, well, 1/2 times 12 is 6, and 6 times 80 is 480. So the area of this gazebo, the floor, is 480. And if we know it costs $14 per square foot, we take 480 times 14, and it gives us $6,720, which will be the cost of the flooring. So volume. Volume is the amount of space inside a three-dimensional region, like the amount of space inside of a box or inside of a soda can. But with regards to what we're learning, volume would be the amount of space inside a room, like a bedroom or a living room. The volume of a room is three-dimensional. So if you're looking at an apartment building or apartment, and you're looking at one of the rooms, then you simply, since it's three dimensions, you have the length, the width, the height, you just multiply those 3 dimensions together to get the volume. So if you have a room that is 14 feet by 16 feet by 8 foot high, the volume is, you just multiply all 3 of those together. So just a little review on volume. You'll have some of those questions. So this example, Mike's bedroom measures 16 by 14 and has a 9-foot ceiling. It's well insulated on the west side of the house. How large of an air conditioner should he purchase? So when you're purchasing air conditioners, there's a unit called a British thermal unit, or a BTU. This is how all air conditioners are rated, and the more BTU, then the more space that unit will cool off. Will air condition. So the air conditioner with the right BTU rating will cool and dehumidify a room. If the rating is too low, then it's not going to cool enough. If it's too high, it may shut off before removing the humidity. So many appliance salespeople use the formula known as while divided by 60 to compute the correct BTU rating. So to find the BTU rating, okay, we're going to find the volume of that room. So W is the width, height, length. The level of insulation is represented by I. If the room is well insulated, I is equal to 10. So how much insulation a room has is going to help you determine how well a unit will cool off a room. If it's not insulated very well, then it's going to have to work harder, the unit will, to cool off the room. And if it's heavily insulated, then it won't have to work as hard. If the room is poorly insulated, then I is equal to 18. So we're going to use this variable I that's going to represent the level of insulation. Well insulated is 10, poorly insulated 18. We're also going to use the variable E to represent the exposure, the direction the outside wall of the room is facing. E, if it faces north, it's 16. If it faces east, it's 17. South is 18, and if it faces west, it's 20. If you haven't figured it out already, but the direction that a room is facing determines how well that room can be cooled off or heated in the winter because of direct sunlight. If that room is facing direct sunlight most of the day, then it's going to be harder to cool off because that room is going to be warmer because the sun's going to be facing that room all day. So here's how we find the BTU rating, and you got some questions on this. So you're going to find the volume, which was the length, the width times the height, and then times these other 2 variables, okay, the I and the E. So in this case, Mike's room is well insulated, and it's on the west side of the house. So well insulated, I would represent 10. If it's west, then E is going to represent 20. So we're going to take all of these numbers. So 16 by 14 by 9. So here's the 16, the 14, the 9. Well insulated, and it faces the west. We're going to multiply all those together and divide by 60. And that's going to give us this British Thermal Unit rating, this BTU rating. So multiply them all together, divide by 60, and you get 6720. So he needs at least a rating of 6720 on his air conditioner to make sure that it's going to do the job appropriately. So they rounded this up to 7,000, so that the BTUs probably come in 1,000 units, so he's going to need one at least at 7,000 units to make sure it works correctly. In this last example, find the recommended BTUs if Mike's room was poorly insulated and the other variables remain the same. So if it's poorly insulated, then I is going to change to 18 rather than 10. So this number would change to 18. So we would have all the other ones the same, 14, 9, 18, 16, and 20. So 14, 9, 18, 16, and 20, multiplying those together and dividing by 60. So they're saying everything's the same except he doesn't have a well-insulated room. It's poorly insulated, so we're going to change that one number from a 10 to an 18. So 14 times 9 times 18 times 16 times 20 divided by 60 is equal to 12,096. So he probably needs at least 12,000 BTUs, if not 13,000 BTUs. If we want to round up to make sure it does the job, then 13,000 BTUs is what he would need that unit if we change that one variable. So you can see it changes based on the insulation.